Hey everyone, welcome to It's a Material World. We're the show that uncovers why material science will change the world. Consider subscribing and hitting the like button down below. It would really help us out. And also, we have a free MSE Company Database categorized by industry sector, location, as well as internship and full-time titles. So if you're interested in that, you can find the link in the description below. Hey everyone, and welcome back to the show. I'm Puneeth, and my co-host is here, David. David, how's it going?
Yeah, not too bad. It's been a pretty hectic couple of weeks, so I'm glad I'm making some time for this, but I'm in the midst of 2 5-week classes, so lots of tests and homework going on. What about yourself, Puneeth?
No, it's going pretty well. I think big news on my front. I recently signed a purchase agreement for a house here in Minnesota, and that was a little bit of a stressful process, but I'm super excited about it. And that kind of ties really well into the topic of this episode, which is smart windows. We really got into what the future of this space could look like and how like the Google Nest, or I don't know if it's Google, it's probably not, but the Nest can communicate with smart windows and save a lot of energy in your house down the line, right? And that's one of my favorite parts of the episode. David, what is something you think the listeners should look forward to?
Yeah, I think Ameen, our guest, is very insightful and has lots of industry knowledge, but one of my favorite parts was his take on sustainable technologies in the market and how for consumers, you really have to make sustainability a secondary or tertiary attribute instead of the primary, because we're just quite not there yet. So his take on the market and how we can make sustainable products viable and profitable was extremely interesting. So I think you should listen out for that because it was a great insight.
Absolutely. Yeah, for sure. And also, so Ameen has a bunch of experience in terms of taking something from the R&D scale all the way to the industry scale. So that's a giant leap, but he's been able to do that with multiple companies or be an advisor in that space, specifically with, I believe, thin film fabrication. Am I right there, David?
Yeah.
So yeah, I think that was super, super cool to see like how much of an impact process control and quality control comes into play when you're operating on the industry scale, and how you have to have kind of this equipment that can make things very consistently. There's really not a lot of room for error. So there's a lot of stuff to look forward to in this episode. And I think it's very relevant, especially for me. But yeah, I think this will be a great episode. One of my favorites so far. So let's get right into it.
All right. Hey, everyone. We are excited to welcome today's guest, Ameen Saafir, the CEO and co-founder of Tynt Technologies, whose mission is to make an energy-efficient smart window affordable for everyone. Just like us, Ameen has his bachelor's and master's degree in material science and engineering. And in addition, he has a passion for using his MSc background to contribute to the more sustainable future. He has been an advisor for eco-friendly companies such as Rainforest Connection, Nano Hydrophobics, and SUNTAP, as well as 12, spanning all areas such as deforestation, solar energy, and CO2 emissions. We are extremely impressed with Ameen's entrepreneurial drive and commitment to improving our planet. We cannot wait to dive into his experiences in his newest endeavor, Smart Windows. Thank you so much for joining us today, Ameen.
Thanks, David. Happy to be here.
Cool. So we can kind of dive into Tint Technologies. You've developed a groundbreaking technology called reversible metal electrodeposition, or RME.
A bit of a mouthful there, yeah.
Yeah, that was a little bit of a tongue twister. And so I guess, basic background research, RME involves metal ions that can be chemically reduced into a film that blocks light and then reversibly oxidized to allow light through. And that creates the smart window technology. But can you maybe dive into how that technology works, and kind of go into detail about what metal ions are used, since this is a material science podcast, and what makes them ideal for this application?
Yeah, and a little bit of the history here. So this technology was developed by Professor Mike McGee, formerly of Stanford. That's where I met him. I did my master's and undergrad there. And he's now at CU Boulder. And so he looked at this about 6 years ago and looked at dynamic windows and all the technologies out there and kind of started fresh, started from scratch. Like if I were to develop a dynamic window technology today, how would I do it? Most of his expertise is actually in organic electronics. And so everyone kind of thought he was going to go that way. But it turns out that metals, as we all know when I say this, are really good at blocking light, right? So you don't need a lot of metal to block out sunshine. And so he started looking at metal electroplating and found that there was a technology that was originally developed in the 1990s by a company called Rockwell, but they weren't able to make it reversible. They weren't able to make it durable. And so he set out to figure out, how can I actually take this old technology and repurpose it for a uniform scaled up window? And so essentially what you're trying to do in this device is controllably create a thin metal film between the pieces of glass, and the thickness of that film then determines how much light passes through. So in the clear state, you don't have any film on that top surface of glass and the light can pass through easily. And then in the dark state, you're growing this thin metal film. And the way it works, the secret sauce is in the electrolyte. And so it's a polymer-based electrolyte with metal ions in it that are slightly positively charged. The metals we use are copper and bismuth. Two very readily available materials. Everyone knows about copper. Most people don't know about bismuth until we say that's the primary ingredient in Pepto-Bismol. So obviously also very readily available, very safe, right? And so these two metals basically work together. And when I apply a small voltage on that, what we call the working electrode, it causes the metal that's very close to that electrode to be reduced. And then it gets reduced to its metal state and it starts forming this thin metal film. That then sets up a concentration gradient within the device. And then so if you kind of think about that next layer down, then those ions move closer. And then when they get close to that voltage, they become reduced. And then in the course of about a minute, you've created a film that's thick enough to block 99% of all visible light. If you keep going for another 2 minutes past that, you can actually go 3 orders of magnitude deeper and really block all light and create blackout. On the other side, what happens if I reverse that polarity? Now I put a positive voltage on that electrode. I then start oxidizing that film again, one by one. It travels back into the electrolyte. And then we have something called a counter electrode on the other side, which today is just a wire mesh that's made mostly of copper. And then those metal ions get reduced on that film. And so they're not disappearing, they're just going from a conformal coating, which blocks light, to a metal mesh, which because of the geometry, you can see through it. And so it looks almost like a screen window, but because the thickness is much, much smaller, you actually don't see it with the naked eye, you can see straight through it. So that's essentially how the device works in a very kind of, simple explanation.
Oh, that's awesome. That sounds extremely similar to a battery. So with that being said, a few questions that arise are, first, like batteries, like for batteries especially, there's like a life cycle. For this, it seems like a very simple and not so like, you don't have to have a perfect film. And so in that manner, is there a lifetime of your product, or basically it'll last as long as the window lasts?
Yeah, so the goal here is to get it to last as long as the window does. And today, a lot of what we're working on is improving that lifetime, or what we call durability of the product. And so what you want to do is set up a situation where every time you plate that metal film onto that working electrode, and then you remove it, that you remove all of it. You don't leave anything behind. And so that's part of what we work on. One of our patents actually addresses that directly by putting a sprinkling of a noble metal on top of that electrode. We can actually get it to coat and oxidize more uniformly. And then on the other side, you've got this metal mesh, and it's a similar type of problem. You want to make sure those metal ions get on that metal mesh, and then when you remove them, they go on and they come off very uniformly. If you can do those two things, you should be able to get it to cycle, indefinitely. And then the third part is in the middle, we have this polymer electrolyte. And as many people know, polymers don't generally like to be exposed to the sun. They tend to degrade and change colors. And so the other challenge is working on improving that polymer so that it's more durable. This, fortunately for us, is a problem that's been solved before in our industry. And so it's just a matter of kind of applying best practices there. So we're working on making it last long enough so that you have confidence when you replace your window that you're not going to have to take it out in 2 years, but that it's going to last 25 or 30 years.
So this seems like, I guess it's very like high technology. So I was just wondering, how difficult was it to go from like that R&D stage to scaling it up to like, a size of a window and producing this at scale?
Yeah, we're actually in that phase right now. So, we're in R&D. I'm in my R&D facility now. It's just about 9,000 square feet. And so we make primarily on a day-to-day basis a 4-inch sample. And we've started making 1 foot squared samples and 16 by 25-inch samples. And so again, this technology is pretty straightforward to make. It only takes us about an hour to make this device, contrary to other technologies like displays, previous generations of smart windows or batteries, which can take sometimes days, right, to fully make. And so it's a very simple process and not that difficult to scale up in size. Some of these big devices we're still making by hand today as we're waiting for equipment to be delivered and dealing with supply chain issues and things like that. So it's a relatively easy technology to scale up. And then my personal experience has been in scale up. For the last 20 years, I've worked on first in displays and then with another smart window company, scaling things up from, test coupon size to whether it be a 40-inch display, which is a big display 10 years ago, or 5 foot by 10 foot windows like I did in my previous company. So this is where my personal expertise really lies, is on how to scale things up. And fortunately for us, this technology lends itself well to that.
So yeah, you really broke down the technology well. And so it was really great to see that. But as you were describing it, it sounded like you're drawing from multiple disciplines like polymer science, a little bit of like battery science, et cetera, in all these different fields. So could you go into like the diverse background of your team and how has that contributed to the success of a technology that does bridge across multiple disciplines?
Yeah, that's a big part of my own kind of personal philosophy of building a team, no matter what you're working on, right? Is like you need to have people from different backgrounds, not just what we typically think about, genders and ethnic diversity, but also academic diversity and different experiences. And so, for the 20 people that we have on our team, I don't think we have more than 2 or 3 people with like the same major, so we've got material scientists, we've got electrical engineers, chemists, chemical engineers. There are times when we've gone out and hired a specific expert because we have a specific problem that we need to solve. For example, I can say like on the polymer side, right? So that's something where we went and found someone who was, one of the best polymer chemists in the world with experience with UV polymerization. And we went and found him to go work on that problem, right? But a lot of our team, comes from different backgrounds. And even if I look at the founders, the 2 guys who did their PhD, one is very much more on the electrochemistry side, and the other is very much more on the material science side, right? And so you really do need all of that. And then think about like, okay, I've told you our secret sauce, the electrolyte. We got to figure out how to coat that. Then we've got to seal the device. So we've got people with mechanical engineering expertise to help understand that problem. And then we're making an electronic device. So we've got to do drivers and control systems. And so we've got electrical engineers on the team as well. And so, pretty much any sort of engineering discipline would find a place here at Tint. And we've just hired an industrial engineer to help us be, more efficient with how we operate our R&D line and the factory that we're planning to build. So it takes all kinds to really solve this type of problem. And what we do see, David, is sometimes, when we're in a meeting, we're brainstorming, you will see, the different approaches from those different disciplines and the way people attack problems. And, I always say, hey, look, if we had 10 people that all, for example, studied under this great professor, Professor McGee, we'd all look at those problems the same way, right? And then we would only see kind of that solution space. But having people that have these different backgrounds, it really helps because you never know where that answer is going to come from.
I guess, so you mentioned you had a ton of experience in terms of that scale up, right, from R&D to industry scale. I was just wondering if you have any general like strategies that have proved very successful in terms of making that jump up? Because that seems to be like a common challenge in this material science startup space.
Yeah, absolutely. So my specific expertise that I developed over the years was in, wet thin film coating. So how do you take a material that's in a solution, get it on a piece of glass, which is mostly the substrate I've worked on, and make that uniform and scale it up. And I've had problems in the past where, you had to get, 1% thickness uniformity over very large areas. And so a lot of that just comes down to, the science of coating and understanding, what it takes to get the formulation right. So getting the surface tension right, getting the viscosity, getting the percent solids right, and then pairing that with the right coating process and the right drying process to get that uniformity. And what you start to understand when you do that is pretty much everything impacts your uniformity, right? So the temperature of the air, the temperature of the substrate, the speed at which you coat. And my general philosophy with that specific problem has been to develop a formulation that you can coat and it stays wet, and then you only dry it when you want to dry it, right? So if you think about, if I'm trying to paint something on glass and I'm going very fast and it's drying very quickly, I'm even more susceptible to, changes in time. What did this part of the substrate see versus this part? And then once I learned that, I started to understand that you could solve most scale-up problems thinking about them that way, which is kind of zooming in on this particular part of the substrate and making sure that this part of the substrate sees the same thing as this part over here. And it translates to a lot of different processes. So for example, if you're going to do a thermal process, understanding how you would design the oven and that process so that every piece of the substrate sees the same exact thing. And that can come into the airflow, it can come into the size of the chamber, it can come into how many maybe different zones you go through, and what is a batch process. So a batch process would be put a bunch of devices in an oven and run some sort of recipe, as opposed to an inline process where they go one by one and each sees the same profile because each zone has a different temperature, a different environment, right? And so it really comes down to figuring out, how can I make a 5-foot by 10-foot piece of glass, for example, look like a 1 centimeter test coupon and have all of those areas see the same thing as this small area does. And so I can generally reduce everything back to that in terms of, again, the wet coating, the cleaning, the thermal processing, even, down to the encapsulation and making sure that whatever you're applying there looks the same in the center as it does on the edge and the top and the bottom. That's a lot of what people deal with. The other side of scale up is really about the volume and doing, one piece after another and making them the same. And again, it's very similar, just making sure you understand enough about what that second, third, and 100th piece are seeing that looks the same as the first one. And that can come down to, how you keep track of your formulation, how you're measuring it to make sure that like it's not changing over time. Again, what your environment looks like. There's been crazy problems I've seen over the years where like seasonal things, right? Where, hey, why are devices look different in January as they do than they do in August? And you realize, oh, it's because the humidity is higher here in the Bay Area in January than August. And I've had problems where working internationally, we had a group in California and then I was stationed over in Korea, and they would send us samples and they would all break. And again, it was a temperature and humidity thing, right? And so the environment in which you process becomes very important when you're trying to maintain repeatability from part to part and from day to day, week to week, month to month.
Do you do all of this like in-house, or do you have any like suppliers? Because I know even like shipping, for example, can really affect like quality control too, right?
Yeah, it just depends on what you're doing. And again, having built up certain kind of expertise over the years, there's certain things that I keep close, right? So if we're doing any sort of coating, drying, thermal stuff, that typically gets done in-house. Things like maybe putting down, metal lines on glass or something like that, that's something we might outsource. There are some things that we outsource just because we're borrowing things from other industries, for example. So, I talked about this metal grid that we have in our device. That's something that was borrowed from another industry. And so we don't worry about making that ourselves. We just get someone to send that. But then you have to work very closely with those suppliers to make sure you understand their process, they understand yours, and that you can optimize it for your application, because this particular thing was not optimized for our application. It was, again, something we borrowed from another application. So yeah, you can do both, and you just really have to understand what you're trying to build, and whether it's done in-house or outsourced, that you maintain those quality standards.
That's awesome. So now we can kind of dive into, I guess, like, why is this technology so important, and what impact can it make on like all around us, right? And so one of the coolest things about this technology is that it contributes to a much more sustainable future. And so from an energy savings perspective, I was just wondering, do you have like quantifiable or qualifiable measures that show how this smart window technology would compare to traditional windows in terms of kind of that energy consumption?
Yeah, absolutely. That's really why I'm in this space and made that transition from flat panel displays to smart windows about 10 years ago. And the Department of Energy's looked a lot at this. They put out a report on smart windows about 2 years ago. And the simplest way to think about this is, a lot of people don't realize about 40% of all our greenhouse gas emissions actually come from buildings, what we call the built environment. And within that, about 30% of that is due to inefficient windows. And so by using a dynamic tinting technology, you can get a 30% savings on your overall energy usage and greenhouse gas emissions over what we consider today an efficient window, which is a double pane window with a low E coating on it. Now, if you've got an old kind of single pane window, which 2/3 of the people in this country have, that ends up being a 60 to 70% improvement. And I'm talking about your overall energy bill, right? So going from $3,000 a year to $1,000 a year, which is a direct impact on greenhouse gas emissions. And if we look at the global economy, the global climate economy, upgrading everyone to dynamic windows, if I could snap my finger, you get a 4 to 5% reduction in overall greenhouse gas emissions. So a giant impact on the environment, right? And so our challenge is to make a product people like and make it at a cost that people can adopt this quickly and have that impact on the environment. I also think about the second order effects where, we can start reducing the peak load on the grid by up to 50%, depending on, how much we can proliferate the technology. And then now you're reducing the load on the grid, and you're letting those next generation renewable technologies get adopted that much faster because you're cutting in half what they have to do, right? So I haven't even calculated what that impact is yet, but we see a big first order impact and second order impact of people adopting this type of technology, which ultimately results in less energy consumption. A lot of the focus is on cleaner energy and things like that, and energy storage. And those are obviously important, but ultimately the way to solve this problem is use less energy, and then it makes everyone's job easier.
I think that's a fantastic point that not a lot of people think about, is that if we are to convert to like electric vehicles or any other green technology, we're going to need a lot of energy. And so how do we provide the energy needed? And so if we can take away from other things, that's only going to help us become more sustainable in general. So I think that's great. One question I did have about the technology is that while you're going to save so much, you still need to use a little bit of power to do that dynamic tinting. How much power is actually needed to like dynamically tint it to be able to maintain these savings? Like obviously it's much lower, but to what degree do you need?
Very little power. And what's nice about this technology is you're only using power in that transition state. So you don't need power to keep it in the dark state. And it's on the order of single digit watts, depending on the size of your window, for a couple of minutes. So it's a very, very low power consumption. And again, it's stable in any state. So from, an energy efficient, and that goes into those calculations of how much energy you can potentially save. So it's a very low power, kind of a funny story. So we have these 4-inch demos that we carry around with us. We're meeting investors, and we powered them, rather than putting a battery wiring it and making it more complicated. We just used one of those, wireless kind of battery chargers, right, that you use for your phone. You know how those work, right? You plug it in, the lights blink and it charges your phone, and then you unplug it and it turns off. And so we plugged in our device and it wasn't working, and the battery kept shutting off. And the reason was it wasn't consuming enough power to tell the battery that it needed to supply the charge. And so we had to add a resistor in there to kind of waste the energy to let the charger know that like there's actually a device plugged in. So they're very, very low power devices.
That's awesome. That's especially cool that once you have the thin film, you don't need to like continually give it anything to become stable. That's a real big benefit. So the energy saving is great for your windows, but also you have other benefits such as heat management, glare reduction, or privacy. Could you go into those properties and how that is much better than what is currently available?
Yeah, it's a little bit counterintuitive, but the way we think about this is we're trying to maximize natural light. And, human beings need light. You feel better when it's sunny out. You feel better when you're outside. And we spend now 90% of our time indoors. It's only gotten worse in the last couple of years with the pandemic. And what happens a lot of times is when it's sunny out, two things happen. One, you feel hot when you're inside because that energy gets in and heats up your space more than you'd like. And we've all been sitting in front of a window and had to pull the curtains down because you've got that radiative heat heating you up. And then the other one is when it's sunny, you have glare, you pull down your curtains or close them or whatever window treatment you have, and you block your connection to the outside world, and you're still getting some of that light in, but you're missing that view and that connection to the environment. And so with a dynamic tint, what you can do is gradually, change the transmission through the windows, much like putting sunglasses on. You can still see outside, you feel much cooler, and you still have that connection. You're getting more natural light. Because they're more energy efficient, I can now put more windows in my building, right, and still maintain the same energy efficiency. We know there's more legislation coming, every month about energy efficiency in buildings, and so I don't have to compromise with putting in smaller windows or reducing windows. One architect I met last week actually is building a house for someone here in Boulder. And if you haven't been to Boulder, if you look west, it's a beautiful view. You're looking to the Flatirons, the Rockies are right there. And but that's also where the sun is a lot, right? And so this guy can't have any windows on the west side of his house because it won't meet the energy efficiency standards. And that's a shame, right? So by delivering this technology or allowing people to live where they want to live, have this connection to the outside world, and adjust the light naturally to do whatever you need to do, whether that's, blackout for sleeping or, more light when you're cooking or reading or something in between when you're watching TV in the evening. And so it's just more of a natural, connection with the outside world.
Yeah, I just got through my first Minnesota winter, so I definitely spent a lot of time indoors. So sign me up to be a first user of your technology. I'll gladly take that.
And think about it, it's the Minnesota winter, and I'm from the Midwest. I'm from Chicago, so I know what that's like. But you can still get that light in, right, and get that warmth from the sun, and it's cold outside, but it feels comfortable in your house without having to turn on the heat. And that's really what we're going for. And here in Boulder, especially, it's very sunny here in the winter. You basically get 6 days of sunshine and a day of snow for about 3 or 4 months. And so being able to, have that connection again to the outside world, naturally heat the home, I think is a really compelling advantage of this type of technology.
Yeah, for sure. That sunlight is a game changer in Boulder. I remember it snowed one day. I went in March, so beautiful, beautiful place. And it snowed one day, and then we went hiking the next day or something like that. And it was like totally warm, but we were walking.
Snow was melted, everything's gone.
Yeah. But yeah, I guess I had a question kind of going back to the material science of it all. David compared it to battery technology. So kind of the first thing that comes to mind is that reversibility. Does that like maximum like peak performance reduce over time, or is there like a limitation of the amount of times you can kind of cycle through that and reverse this dynamic aspect of it?
Yeah, fundamentally, that's what we're working through, right? Is just like a battery. There is some finite lifetime to these types of devices and technology, and we're just trying to improve to make it, good enough to be in a window. Thankfully, we're not stressing the device that hard, but it's challenging. Our industry has kind of set the standard of 50,000 cycles. In terms of being able to last 20 to 30 years in a window, and you don't cycle batteries 50,000 times, right? So in some ways, it's much, much harder, but in other ways, it's not as hard just because of the electrochemistry that's in play in this particular device. So we're working through that. Again, we're a pretty early stage company. We're able to last a few thousand cycles now, which is good enough for some of the entry level products that we're looking at. But a lot of our resources go to just extending that out to, 30, 40, 50,000 cycles.
So yeah, I know your focus right now, you just said, is like getting your life cycle longer, but down the road, it sounds like this could be used to be in tandem with like your AC condition or your TV or other parts of a smart home. How do you think IoT plays a role in the benefit or the value addition that your windows could provide?
Yeah, and that's a big part of what we want to do. Is the way I see it is a smart home. You think of a smart home today, and like you look at smart home builders, like they're just selling you a bunch of stuff you go buy at Best Buy, right? They're selling you, a doorbell and a thermostat. It's your home's not really smart, right? And I think if we think about like how our world is changing, the best thing a smart home can do is be energy efficient and adapt to the changing conditions throughout the day, throughout the seasons. And that starts with the window. And so what we see as the home in the future is something that responds to the climate outside, starts with the transmission, thermal energy coming through the window, and then lets the rest of the house know what to do to compensate for that. So for example, let's say it's very sunny and hot outside. You need to darken the window more than you normally would. Okay, so now let's tell your Philips Hue light bulbs to turn on and give me comfortable light because it can't quite use as much natural light as I want to today. But also, hey, no one's in the spare bedroom today, so just black that one out, turn off the vents in that room, and then, I don't need to divert any sort of air conditioning to that room. I just need to keep it cool enough to not like overheat the space, but it doesn't need to be 68 degrees, right? And so I really see it starting with the window and then telling all of those other devices what to do to maintain that comfortable environment. And that's really a lot of what we're looking to accomplish at Tint. And if we look at kind of our business model, our go-to-market strategy, it really is around delivering the window and not just like selling this technology to a window company, because we don't see other people out there with this sort of vision, nor the technology to do it, right? So you kind of need both, and that's really what we're all about.
Yeah, and in turn, that could also lead to a drastic reduction in your electricity bill too, right? So I guess in comparison, right?
Yeah, and then also changing the way we use our spaces, right? And so I'll give you another kind of anecdote here. In Colorado, everyone has basements, right? And I think they do that in Minnesota as well, not in California. But, a lot of people, my home included, we have like our TV movie room in the basement. And so, we always have this debate where we're eating dinner in the kitchen. And the reason it's in the basement, it's a lot easier to control light down there. It's a lot easy. We do have some windows, but not nearly as much as we do, in the living room. And so we'll eat dinner and we'll be watching TV. And then my wife will say, let's watch a movie. And I'm like, all right, let's take everyone down to the basement. And so if you have this ability to really control light in the living room, that can then become your real movie room, right? You don't need to move everyone to the basement. And your basement can be some other space. It can be a gym, it can be an office. You can turn it into more living space if you need to. And so you can really just not just maximize efficiency in terms of energy, but also how you use your space. One of the cool things we want to do in the future, potentially integrate things like, transparent OLED displays into your window. And then again, now I don't need a TV and a TV stand and all this, it's just the window, right? So there's a lot of things that we're thinking about that can be pretty cool if you think, 10, 12, 15 years into the future.
That's awesome. So speaking of that, what do you think is like the next step or like that first application? So you're saying kind of like in terms of the scale up from size, it might take maybe a little while to get to that full size, like my apartment window or whatever. So what is kind of that next step? I'm thinking like a car window, or is there something even smaller than that you can get into?
We're going straight for windows. So right now, we're actually planning to build a facility to make windows up to 4 foot by 5 foot windows. And so that gets you most of the market. Our first product will be something on the smaller, kind of end of that size range, but we want to be able to really get, we're looking to make enough units in this next phase, really understand the market, and we've got to make them big enough that we get some real world use application out of that. And so, we won't be making, floor to ceiling windows right away. That'll be a few years out in the future, but enough where you could, put a few windows in your home, understand how this technology works, and then beg us to make more, right? So that's kind of the idea of the next phase.
And so as the innovation grows and your product becomes more final, one big thing that you've talked about a little bit is how do we take all these windows that are currently in homes and retrofit them to these new windows? And Tint is working on addressing that. Could you kind of explain the strategy behind allowing the retrofitting of old windows to these newer windows?
Yeah, I can talk about a little bit of that. I will say that's a big part of our strategy here is if you look at what's out there today, you get about, we look at the US and Europe, and so you get about 130 million windows sold in the homes every year, and about half of those go into new homes and half go into existing homes as a retrofit. But there's 10 billion windows out there between the US and Europe. And so to make an impact, you got to figure out how to get those people who weren't planning to upgrade their windows to adopt this technology. And so that's the hard part of the market to reach. We're looking at ways of doing that. For example, rather than replacing your window, having an insert that goes inside your window that would give you maybe 80% of the energy savings and 100% of the comfort improvement at a much, much lower cost than replacing all your windows. So that's one way to do it. And then longer term, there's some other cool things we're thinking about in terms of, we've got the ability to make this technology on plastic. And so maybe just being able to laminate, for example, our film inside your window, and then it becomes a very, very low cost, highly scalable solution that anyone could adopt to, get these benefits.
And then I guess from the business model side, or more from like the sales side. So I know with solar panels, right? Like they kind of pitch like, here's the potential cost savings over like a 15 year time period. Is that something that you think could work in this business model, as well as like, oh, here's the potential like electricity savings over X period of time?
I don't think that works in solar. So no, I don't think that's going to work here, right? I think that my fundamental thesis about this is that unfortunately, people don't spend money to save energy. It's just not something that your average person does. If we did, everyone would have solar panels by now, right? Because they do pay back over time. It does save you energy. It can definitely improve your life, but there's a very, very small percentage of the population that does that. You can look at electric vehicles as well, right? How many people had electric vehicles before Tesla? Almost nobody, because they were awful, right? And who wanted to drive around in a Nissan Leaf, right? So my thesis here is you've got to make a cool, sexy product that happens to save energy, and that's the way to make this happen. And so that's why we focus so much on the color, on getting the blackout, on how the software works and the user experience, so that like people are out there saying like, I want this in my house because one, it's really cool, and two, it makes me more comfortable. Oh yeah, it saves energy, but like that's not why I bought it. And again, I bet if you poll, Tesla drivers, like, yeah, there's this kind of, okay, it saves energy, but finally I've got something that's cool enough. It's fast, it's sleek, it's comfortable, it gives me all the things I get in a luxury car, and it also saves energy. And that's more the way you sell this technology. So, unfortunately, I don't see solar really getting to the type of market penetration, at least as a homeowner, that we would really like to see. I think solar eventually is basically going to end up being what we use to power our grid. And then with homes, you're going to start seeing home design move more towards reducing your energy consumption, again, with things like smart windows, with things like, as you mentioned, David, the IoT integration, with things like your Nest thermostat, your Flare smart vents, and things like that. So yeah, unfortunately, I don't think that model is going to work here, and I don't think it works very well in solar either.
Interesting. Yeah, I guess I had like one sample size where like one of my professors from Georgia Tech, installed solar panels onto his house, but guess he has a lot of like battery research and things like that. So that might not apply to everyone.
You know, I looked at it for our home, you know, and one of the things that we decided was like, when we have 2 electric cars, it'll make sense to do solar. Until then, you know, it doesn't. And then also with the grids moving that way, it becomes less compelling to spend that $25,000, $30,000, $40,000 on that when you're already going to be getting that clean energy in the near future, right? So yeah, we really look at trying to shift consumers' mindset, homeowners' mindsets from don't think about generating clean energy, think about using less energy.
I think I never heard that point of view before, but I think it's especially poignant, especially when you look at like Tesla's solar roof, is that the entire design is that it doesn't look like solar panels. It just looks like a regular roof. And so really making it sleek and sexy, like you said, is it kind of unfortunate that we have to think about that to like save and be sustainable,
Right.
but it's how the consumer works. So you have to cater to them.
Do you see that in the future? Like, I guess, you know, the next generation is maybe more cognizant of just like creating that more sustainable future and maybe more willing to pay for that, like with their wallets? Or do you still kind of see it like long term, it's still more like about making that sexy product, like that brand recognition, like Tesla has, more so than banking on consumers just willing to pay for something that's more sustainable?
I hope we see that change. I'm not going to bet my company on it though.
Yeah, fair.
And we employ a lot of people that are, you know, kind of the next generation that are kind of just finishing up grad school and things like that. And I definitely see them as being more climate conscious than my generation was at that point. But also they don't yet have the disposable income to be, you know, really the target consumer for a lot of these new technologies. Now, again, eventually you want to get mass market and be able to have everyone have this technology. But yeah, I don't know. I don't know that I have a great answer of what I think is going to happen. I think you'll see more. What I see though more in that generation is more of the personal habits changing as opposed to spending money. So you do see people, you know, doing things like riding their bike to work more, you know, people talking about, you know, not planting grass, and a place like Colorado, for example, you know, that's basically a desert and things like that. But I don't see people, no one drives an electric car here, for example, in that generation, right? So I'm not seeing people really spend, because right now it costs a lot of money to be climate conscious. Like Teslas aren't cheap, solar panels aren't cheap, right? And so I don't think it's really penetrated that generation yet. So yeah, that'll be interesting to watch.
Yeah, for sure. So I guess bringing it back to MSEs, like what do you think material scientists can do, you know, at your company or just in this industry as a whole to make smart windows like more accessible for everyone down the line?
Yeah, you know what I love about material science and why I chose it is it kind of felt like this major and discipline that kind of sits in between and adjacent to everything, right? So there's not much out there from a technology standpoint that gets developed that doesn't need sort of material scientists input. And so, you know, specific challenges in our space, again, with the durability, a lot of that is a materials problem, right? So understanding polymers, how they degrade, how you can improve that through composition, through processing, things like that. That's a big problem. The other one is sort of the mechanics of what happens in a window over time. And, you know, you're getting, you know, different stresses and strains on your window because of whether it's wind loading, whether it's thermal loading, whether it's, you know, hail impact and things like that. That's one of those material scientists / mechanical engineer problems, right? But understanding those types of things and just in general, I think material scientists are really well positioned to understand things like durability, reliability, and longevity, right? So that's part of it. And then typically your typical material scientist, right, goes and becomes a process engineer, right? That's always been, at least in my generation, your preferred route. And understanding those problems I mentioned before with how do you make a lot of these, how do you scale them up, how do you make this process repeatable? Do I really understand that connection, right? That material scientist connection between, you know, the structure of the material, the way I process it, and what the properties are, right? And so there's definitely a home for material scientists in this industry.
And so that's great about like how MSCs can affect the industry. But do you have any advice for MSCs who want to take a different route, like entrepreneurship, like you have, and any advice on how they can at least follow some of their dreams?
The biggest thing I can tell you is the first thing you need to do is become an expert in something, become the world's expert in something. And that's where it all starts, right? So I can give you a little personal story. I started a company about 11 years ago now, making iPad apps for kids. And it was something that was just kind of a cool thing that we came up with a group of friends of mine. And, I was pretty good at doing things like building a team and building the product. But when it came to go out and like take it to the next level and raise money, it was always kind of like, well, who are you to do this, right? Like, what do you bring to the table that the other 10 people don't? And so that was a big hurdle for me in that endeavor. And now I flip it. Now I've got 20 years of experience, and you don't need 20, but scaling things up, right? And now people say, oh, I see why you are the one person on the planet that is the best position to lead this particular company, right? And so, if you're passionate about something, go study it, go work on it, go do your PhD or postdoc, whatever it is, become the expert in that so that you can speak with that authority so that people are thinking about you. Because a big part of it, one of the hard things about entrepreneurship as an engineer is like, you do have to raise money. You can't do this in your garage for very long, right? And so and that's what people invest in. They invest in people, they invest in that expertise that they see as unique. So I would say the first step is go become an expert in something and become literally the world's expert in it. And, I could stand on stage with bring anyone you want who's done coding, who's done scale up. I'd be on stage with them, be totally comfortable and call myself a world's expert in that thing, right? And so that's the kind of background you need. And if you look around, right, if you look around at a lot of the, deep tech, hard tech, climate tech, whatever you want to call them, companies out there, you look at the founding team, that's what they are. They're the expert. They did their PhD on it. They did a postdoc on it. They worked in the industry for 5 or 10 years. And that's where it starts. So coming out of, undergrad, coming out of a master's, I think it'd be pretty tough to get the kind of traction, but PhD, postdoc, master's plus 3 to 5 years in industry, you've seen enough problems. That's sort of the foundation I think you need if you want to be kind of at the top of a company as an entrepreneur.
Yeah, that's great advice. That was an awesome episode. I definitely learned a lot, but I was just wondering, is there anything else you'd like to add to kind of wrap up this episode?
Yeah, again, thanks for having me. I love doing this kind of stuff and kind of giving a little, glimpse into your future, right? As you're coming out, I wish I had someone to do this when I was coming out of school. So happy to do that. I will plug Tint here. I think we're raising money right now, so we're actually going and raising a Series A, which will help us build this facility, get our products out, and then alongside that, we are hiring. I say we're always hiring because I'm a pretty opportunistic person, and so when I find good people that I think can contribute, maybe we didn't have a role, but like we find a role for that person, and so I pride myself on creating a really great, diverse atmosphere here. Our team is 50% female-bodied people, which I'm very proud of. We need to work on the people of color a little bit, but we're working on that. But it's a very, I think it's a great opportunity for, especially an early career engineer, material scientist who's looking to learn from an experienced team. Our leadership team is very experienced, but also work in that kind of high-paced, high-energy, younger kind of environment in terms of the engineers and scientists that are, solving these big problems for us. So, yeah, if you're interested, send me a note, Ameen@tint.io, and would love to chat with anyone who's interested. So.
Sounds good. And ultimately contribute to a more sustainable future. So
absolutely. Yeah. One more plug. And I did this when I gave a talk at Stanford for Material Science Group a couple months ago. And I just would say, I would implore all of you material scientists, whatever you do, please, 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 please go work on climate. It is the problem of our generation. It's the only thing that matters right now. I don't care if you're working on solar or smart windows or batteries or CO2 sequestration, just go work on climate. The money is there now. The investors have finally gotten it that this problem, one, needs to be solved. The money has to be there to attract the talent to do it, and that you can actually make money solving these problems. So just please, if you do anything, go find a climate company to work at. If you've got questions about who I should go work for, let me know. I'll also plug 12. They're my favorite company I've advised. They're on fire. They're going to be hiring a bunch of people in the next year or so as well. But just please go work on climate.
Awesome. That's a great way to end the episode. So thank you so much for joining us, Ameen. It was an absolute pleasure.
Yeah, Puneet, David, I had a great time. Thanks for thinking of me, and looking forward to seeing more people on future episodes here.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.